Okay, so next we want to graph each of these things over here. You know what? I forgot to say that this was a line. So let me say this is a line up here. Okay, through the origin. Okay. So the next thing we want to graph is we want to graph this r is equal to 2 cosine theta. So what we're going to do first is we're going to graph it in Cartesian coordinates. So on this side would be Cartesian, and on this side will be polar. Okay. So I want to graph this in Cartesian coordinates. And when you look at this guy, this 2 right here, this is a vertical stretch by 2. Okay. So so maybe I'll do cosine first. So let's say this is a 1 here, this is a 2 here, this is a negative 1 here. Oops. That would make this a negative 1 here, and this is a negative 2 here. And this is supposed to be 0, pi over 2, pi, 3 pi over 2, 2 pi. That 5 typical points for a period of cosine. So cosine starts at 1. So let's graph cosine first, and then we'll graph sine. Cosine starts at 1. We'll do it in green. Then it goes to 0. Then it goes down to negative 1. Then it goes back up to 0. Then it goes up to 1. So one period of cosine looks like this. That's not what I actually want to graph. I actually want to graph 2 cosine theta. So this is just y is equal to cosine theta. The actual graph I want, let me do it in navy. So the amplitude will go up to 2, back to 0, down to negative 2, back to 0, back up to 2. So this part looks like this. It's important to make the sound effects when you graph this. Now, since the graph I actually want is the y is equal to 2 cosine theta, let me just delete the green one. I just wanted to show you the graph of cosine first. So let me wipe that guy out, wipe this guy out. Okay, this is the guy that we want to graph. And what we're going to do is we're going to graph each of these points. So when theta is equal to 0, we're facing this direction. And we're going to go out a distance 2. So I'm going to go out 1, 2. The distance 2 is right there. Okay. So that's that point. When theta is equal to pi over 2, which is this part right here, we're facing this direction. Okay. And when that occurs, we're going to go out a distance 0. So what do you notice that's happening? What you notice that's happening is that we're going to go from a radius of 2 all the way down to a radius of 0. So if I were to graph that, kind of what's happening is we start off at 2, and then the r gets smaller and smaller, not a straight line, sorry. The r gets smaller and smaller and smaller and smaller until you end up at 0. Looks like this. Okay. What happens next? What happens next is that when I'm facing this this next point right here, this next point is pi. So when you're facing pi, you're facing this direction. That's pi. But what's happening to my radius? My radius is going to be negative. It's going behind me. So when I go behind me, that means I'm facing the pi direction and I'm trying to draw behind me. So when I go behind me, I go distance negative 2. So negative 2 actually takes me back to the point, back to this point right here. So I'm actually going from pi over 2 to negative pi, pi over 2 to pi, but all the r values are negative. So when that happens, that means I'm going to get something that looks like this. Now I kept highlighting that so big that it became a giant blob. So let me redraw that. So it's going to go behind me like this. Takes me back there. Okay. So what's happened is I've gone from 0 to pi, and I've already traced out this object that kind of looks like a circle. So now let me delete these two parts. Okay. So what's happening now? So now I'm facing, I still had that, this is pi, I'm facing, this is pi. Then for the next part, what I'm going to do, for the next part is I'm going to go from pi to 3 pi over 2. So 3 pi over 2 means you're facing in this direction. But what do you notice about all of these r values? These r values here, I don't think I told you that this axis is r, this axis is theta. So what's happening is that your r values are going to be negative. So think of it this way. You're going from pi to 3 pi over 2. But when you draw this part, you're going to actually draw behind you. So what we're really doing is we're really repeating that first segment that we got. So this is this graph again right here. You can't see what I'm doing, but I'm graphing this part yet again. Okay. And that takes us back to the point 0, 0. Or rather, it's 3 pi over 2, 0, which is the same thing as the origin right now. Okay. So now let me erase this, this, and this, and this, and this, and this. We've graphed that part already. We've graphed this part already. So now we're trying to look at the last part. So for the last part, we're going to go out to 2 pi. So going out to 2 pi is this direction here. That's 2 pi. And so what's happening as we go from 0 to 2 pi, my radius is going, the y values, the radius, sorry, is starting at 0, and it's getting highlighted all the way up to 2. So as I go from 3 pi over 2 to 2 pi, I'm facing this direction. My r is positive, so I end up graphing that bottom part of the circle all over again. And that's this part. Okay. So what happens when I graph this? We get r equal to 2 cosine of theta. This is really a double circle. Okay. So we have that. Now, how can you guys see that this is a double circle? Check this out. Let me multiply both sides of this equation by r. If I multiply both sides of the equation by r, I get r squared is equal to 2r cosine theta. But we know that r squared is x squared plus y squared, right? And we know that r cosine theta is x. We know that this guy is x. So this is equal to 2x, right? So what does this give us? This gives us x squared minus 2x plus y squared is equal to 0, right? I want to complete the square over here. So to complete the square, I take half of this guy right here and I square it. So half of negative 2 is negative 1, and I square that. That means I'm going to add 1 to both sides. So when I do that, I get the equation x squared minus 2x plus 1 plus y squared is equal to 1. But this front part is a perfect square, and that guy becomes x minus 1 squared plus y squared is equal to 1. This is a circle of radius 1. Centered at 1, 0. And when you look at our graph up above there, that's exactly what we got.